The next concept is event. An event is one or more outcomes from a sample space. It's a subset of one or more from the sample space. Okay. Now, so if you define event in that fashion, so for one example would be roll of a die. You get 1, 2, 3, 4, 5, 6 is a sample space. Now, even number is a subset of that, 2, 4, and 6. So that would be an event. Odd number would be another event, or a number below 3. That's another event. Now, how do you compute the probability of an event? So probability of an event is, again, like before, you count from the sample space is a set of unique outcomes. Now count how many of those outcomes are defined by the event. Okay, so the number of outcomes define the event divided by the total number of outcomes in the sample space. So again, going back to the roll of a die example, experiment is roll of a fair die. Number of outcomes in the sample space is 6. Suppose if we define an event called even. So how many outcomes are there in the event? There are 3 of them. So probability of even is number of outcomes in the event divided by the number of outcomes in the sample space, which is 6. So that's 0.5. Okay. Let's look at another example. Suppose we randomly draw a single card from a deck of 52 cards, right? So one card, with drawing one card at random. So how many possibilities are there in the, well, the sample space is what? Sample space is each card, all the face cards, all the number cards, everything from ace to king in all the 4 suits. Then there are 52 possibilities. Okay, so that's our n. And suppose if we define an event that says the card that we draw is a spade card. Okay, so that case, now you have to go back to our sample space. There are 52 of them there. Okay, how many of those outcomes would satisfy the event definition that it is a spade card? So how many of those 52 outcomes will be spade? So that will be 13 of them. So the event is spade. So k, the number of spade cards, is 13. So now probability of spade is k divided by n. K being the number of outcomes in the sample space that satisfies the event, and n being the number of outcomes in the sample space. Okay. Now let's same experiment. Okay, draw a single card from a deck of cards. Then suppose if we define the event as a face card. Okay, how many face cards are there? So in each suit there are 3 face cards. There are 4 suits. There are totally 12 of them. So k is 12. So that 12 divided by sample size of 52. So that will give us the probability of a face card. Again, let's format this to 4 decimal places. So that is event and event probability. Okay, event is a subset of one or more of the unique outcomes in the sample space, and the probability of an event is how many of the outcomes in the sample space is defined by the event divided by the total number of outcomes in the sample space, which is n.